이분이 한국 분이시기도 하고 그래서 저도 랭귀지를 한국말로 편하게 좀 하면서 나중에 토론할 때 제가 질문을 던진다든지 아니면 때로는 싸움을 붙일 수도 있습니다. 그래서 그럴 경우에는 뭐 영어로 좀 같이 해서 하도록 하고요. 지금 그 소개한 대로 저희가 네 분의 프레젠터가 있습니다. 그래서 각각 한 20분 정도 맞춰주시고 그 다음에 질문은 제가 보니까 전 세션에 와서 잠깐 들어보니까 다 끝나고 난 다음에 전체적으로 모아서 질문을 함과 동시에 이제 그 이슈 파이팅을 제가 생각할 때 한 두세 개 정도를 제가 들으면서 이슈를 생각해내겠습니다. 그리고 여러분도 이슈를 발굴해 주시면 감사드리겠습니다. 그래서 발굴된 이슈를 서로 쉐어하고 또 그거에 대해서 한 두 개 정도만이라도 한국에 도움이 되고 전 글로벌리 유스풀한 그런 인포메이션을 도출할 수 있으면 좋겠다고 생각합니다. 자, 그러면은 우선 첫 번째 프레젠테이션을 저쪽 가서 제가
Dr. Choi, thank you for the organizer and sponsor for this forum. I'm honored to be here at the International Symposium for Smart Cities here in Korea. And today my main topic is about the cooperative intelligent transport system in smart cities. Thank you. So when we're talking about, for those actually who are not familiar with C-ITS or Cooperative Intelligent Transport Systems, it's basically the data digital the exchange between the road users and the traffic managers, usually through wireless connectivity, whether vehicle-to-vehicle, V2V, or vehicle to infrastructures. And today, when we cover a lot of the topics on smart cities, one of the perspectives are on mobility. So that's why my topics, on a certain segment of the overall smart cities theme. And then when we're talking about autonomous, about mobility, the automotive industry is actually now moving forward, electrified, autonomous, and digitalized. So, in the foreseeable future, we'll see the complexity of managing legacy vehicles, connected vehicle, and autonomous vehicles in a transport system. So that's something actually I'd like to address today. Before I move forward, just allow me, just a couple of seconds just to introduce Ericsson. Ericsson is a Swedish-based company with a history of 142 years, mainly in information and communication technology. We in Ericsson would believe that our vision is to enable the full value of connectivity for service providers across the world. So in short, we believe anything that can be connected should be connected, or in short, it's Internet of Things, IoT. And then we realized that by three pillars of our strategy, we leverage the technology leadership, especially in 3GPP, which is, for example, 3G, 4G, 5G. And then we leverage our product-led solutions, which mainly in the area of network, digital services, and emerging businesses. And also we leverage our global scales and skills, which leverage our global presence across more than 180 countries and approximately 97,000 employees around the world. And finally, we are proud to say that for every single phone calls you're making, or you're serving on your neighbor, or using your KakaoTalk, 40% of those data go through a network operated by Ericsson. So before I move on to the next slides, I would like to change something different, to give you some energizer. Please allow me.
Ericsson is hitting the street. We're making the daily commute and finding new ways to work. We're in the subway and in the bus shelter. We're in the truck stop and at the station. So what are we doing there? We're connecting everything. That includes vehicles, infrastructure, and you, making it possible to put safe, autonomous vehicles on the road. We're supporting businesses as they redefine the way they work, and we're enabling ecosystems to support the transition to electric-powered transportation. Making this happen is all about making connections. With our cellular technology, management and monitoring solutions, and a marketplace that can travel anywhere in the world, we're making things easier. We're connecting automakers with city planners and traffic officials, with fleet owners and logistics companies, and the app developers and service providers. We're on a journey together, a journey to get the job done, to get home on time, and to make our communities better places to live. Join us on that journey.
Thank you for the video. So a while ago, when you watch the video, most probably something that you picked it up from the video is logistic, transport, trains, fleet management, and connectivity, which all of those are addressing the mobility. I'll talk a little bit more why Ericsson is actually in the smart cities game. But here, first I'd like to go through the industry trends, a study actually conducted together with leading research institutes and looking at the smart cities. And then how we see that is that it's, from the market overview, the potentials or the expansions is actually on a couple of layers, underlying ICT infrastructures. Data and common digital assets actually, whether it's from security camera, it's from traffic lights, it's from solar panels, it's from battery bank, or even the data from your phones. This enormous data will be part of the smart cities data, that how they can be commonly managed, shared in a secure way, and also monetized. So those are three things actually that we observe the requirements from the market. And also from a city service perspective, whether there's a new catering, new needs actually we saw from the market in terms of, for example, traffic and tourism, public administrations, those services. On the other hand, the industry challenge that we see is actually it's a very politically driven process, and usually not necessarily that policies are in code with technology. Sometimes technology is in advance, sometimes technology is lagging behind. So that's a few things that we saw from the industrial challenge. Also the growing population expectation from this smart type services. And also the current vertical approach, mostly that we address in use cases per specific industry, is not long and sustainable. We see that the requirement is actually on the horizontal approach, which I also pick it up from some of the previous speakers and notes. And there's also a limited technical competency even from the project management perspective. We see that to manage such a complex transformation project in the city scales. Also from the financial capability of implementing such a transformation journey, we asking the question, where do we get the money? So those are some of the industrial challenges that we saw. And then from a business perspective, based on the same study, that we saw that approximately there will be $2.4 trillion by 2020, and then it's a mix of 55 and 45% each on the vertical segments and on the industrial segments. I would like you to take a quick look on the industrial segments first. As we research show that the majority of them will actually on the logistics and transport, followed by public planning administrations, and then followed by smart utility and security. So that's why one of the angles we look into this, or our Ericsson approach, is basically based on this study. And from a horizontal perspective, that we see, require a platform that can handle infrastructure management, connectivity management, asset device management, service information service management, operating center management. So those are findings from the study. Then why Ericsson in smart cities? So there are three things. First, we are leading in provider for connectivity. In the end, when you want to connect everything in smart cities, from like a data center to all the way to like a smart meters or like a parking devices, you require connectivity. Not everything can be done by wire. So wireless is actually the way to go. I mentioned about 40% of the data traffic go through Ericsson's network equipment globally already. And then with the 4G and 5G technology deployment, we will see that this will enable the more use cases, that's all the use cases on smart cities that will happen. From end-to-end capability, since we have done numerous complex transformation projects on the telco, so we understand how we can do planning, deployment all the way to operations. And then we are also horizontal assets that address the horizontal needs. And finally, we in Ericsson believe in sustainability focus. We work actually with the United Nations on looking at the sustainability. And we think that's how we drive the future. So in most of our IoT or our future current IoT related solutions, we look very hard on the IoT, on the sustainability focus. From a value chain perspective, as you can see, from device and hardware connectivity, network, service enablers, those solutions integrator and use case providers, we see that the value distribution is actually shifting mostly on the service enabler and then use case provider perspective. So that's why our Ericsson IoT focus is on the service enabler and also the use cases together with our communication service provider in Korea, which is SK, AT, KT, and LG, for example. And then also with the ecosystem partners, because we Ericsson we cannot do everything, and the scale is too humongous for one player to take it all. So that's why that's our approach and also our go-to-market strategy. Okay, so in Ericsson, so our take or our approach on the smart cities is mainly first talking about the horizontal platform approach. Second, we talk about in Ericsson we're looking at the environmental monitoring, whether it's water quality, air quality, noises, and so on, and powered by IoT cellular technology, for example, like NB-IoT or LTE-M. We look into smart building, smart office, which is actively utilizing these spaces in the smart city settings. Connected urban transport, which is our answer to part of the cooperative intelligent transport system, which I'll talk a little bit more later. And then finally, our game with the ecosystem, whether it's logistics, it's smart utilities, it's smart parking, and so on. So for the reality and transport system, so in fact, while I was listening to the previous speakers talking about the complexity of the siloedness, the complexity of the smart cities, actually not very far from actual transport segment as well. Because most of the time, the traffic authority, they have, because of the mix of vendors, legacy, standard, and life cycle management, most of these infrastructures, they're not exactly digital, or at the same time, their infrastructures are siloed, the system cannot actually talk to each other, and not to mention across different cities or countries. And then also the market is very fragmented and complicated, so the data could be utilized with, let's say, one fleet management company, and then maybe one bus company has their own system, the tram company has their own system, but then all these data are very fragmented, and that's something actually we want to address, how to manage all this data digitalized and centralized, put somewhere that actually people can manage and finally monetize. So the connected urban transport, our answer to the C-ITS, we're saying that in the system we'll be able to optimize the operation using of the current infrastructure, whether it's sensors, variable message signs, traffic lights, camera, and street light, and so on and so forth. At the same time, open up the data that can be utilized for city planners, service providers, data brokers, information centers, and so on. And a few of the key features in the CUT or connected urban transports is we have dashboards, automation, KPIs, and ecosystem. Dashboard, a graphical interface, a cross-system which enable faster and easier troubleshooting when incidents arise over city planning, traffic planning, and this data is shared across different agencies. Automation, we use the rule engines in the system to be able to trigger automations when something happened. Actually, the message will be triggered whether SMS or phone calls or an email to the relevant key stakeholders to trigger for the next action on the traffic setting. KPIs. For the KPIs, you will be able to monitor and visualize the progress, benchmark, the service layer agreement, and basically track the long-term effect of a certain traffic setting, for example. And ecosystem, the data is also exposed to third-party vendors so that they can utilize the solution, they can and utilize the data. At the same time, we have something called deep link. And basically, we can say it's embedded the certain solutions of a third-party vendors. So those are our key features. So when we're talking about benefits, in short, it's about optimizing the operations using existing city infrastructures, and they enable the new use cases around the assets management, whether it's a smart parking, a security camera, it's smart street lights, it's waste bin management through several IoT technology. And then finally, the exchange of data between different, whether they are bus company, they're fleet company, they are even mobile phone. I'll just take one example, to give you a concrete idea of what happened to be precisely. So for example, there's a traffic light broke down somewhere. Then through the system, you go back to our intelligence system and triggers like, okay, let's send an inspection car to the site to fix it and see what's happening. At the same time, it trigger of closing their certain intersections. And then at the same time, the data will go to whether bus company or a taxi fleet to tell them, let's avoid that area until further ado. Imagine all this data used to be isolated and between different agencies and systems. Right now, through the system, we want to approach the better efficiency in the traffic management. So I'll share 3 use cases. The actual use case we're done with the solution. The first one is Drive Sweden, which is an innovation project led by Swedish government, together with leading technology companies like ourselves, Ericsson, Volvo, Scania, and also the city municipal, like the city of Stockholm and Gothenburg, and the traffic and Swedish road administrations, and finally the universities in the cities. This joint effort together to address 2 things. One is the leadership in autonomous transport, and second is actually the mobility services. And when we're talking about autonomous transport, we're not talking only about passenger vehicle like Tesla. We're also talking about buses, talking about bicycles, talking about the last mile transportation vehicle, which is the one that you saw, like small little bus in the video. And then the challenges, of course, how to do this securely and efficiently, and how to become a leading in this space. So the solution we have is first one is a joint development roadmap together with all these key stakeholders, and then try to define a roadmap for the next 12 years. Who's going to do what? The second thing is actually this cloud-based solution. We put it together as an innovation cloud, holding all the data for exchange. And finally, once this data is held in a certain place, how to broker it, because we, Ericsson, we don't own the data, but basically to share the data between key stakeholders, and very important how to monetize it. So the benefits of it is it enabled efficient information exchange between the roadside vehicle and cloud and real time. And also because this is based on IoT cellular technology, it helps future-proof and also for future expansion scalability. And it helped putting attention on mobility services and autonomous vehicle. And finally, it helped monetize the data, which will extend benefit to all the ecosystem. The second example is City of Dallas. So City of Dallas, or DFW, is actually in Texas. Is the fourth largest city, metropolitan cities in U.S. Like most of the metropolitan areas, it has the problem of how to effectively and efficiently moving people and objects from A to Z, from point A to point B. Second, how to cope up with the growing of populations and how to build infrastructures. Third, how to, despite all of this, how to reduce the OPEX. And fourth, how to reduce the carbon footprint. So the use case in Dallas, City of Dallas, is basically, first, how to find a way to check the status before information exchange between different agencies. Second, it's implementing and maintaining the coordinated traffic plan when something arrives, when certain incidents arrive. And then third is how to real-time analyze this data for long-term city planning. So again, in this solution, we use the cloud-based solutions. And then we also have a traffic, 24/7 traffic operation centers using the system to do the monitoring. And the benefit is now the intelligent visualization is possible of visualizing all the data. It helps more efficient workload via automation, and it helps quickly troubleshooting of incidents. And finally, the third case is I want to bring it is actually the Dutch Minister of Infrastructures. The project they call is Better Benutten, or Talking Traffic. So some of their pain point is basically first how to reduce traffic traffic congestions without building actual new roads. Second, how to digitalize all this legacy infrastructure's data and put them in the cloud. And third is how to actually exchange them between different key stakeholders in the ecosystem. So by doing the same solutions, we're able to help enable the national cloud platform for all data traffic in real time. And then this information is now sharing between the roadsides and vehicles. And then because this is real time, it can start from a small portion of the Netherlands, but in the future it can expand it to the whole city, the whole country. So, and this is my last slide, talking about the takeaway. Today we're talking about first, smart city is a very complicated project and concept, which I don't think anyone here would deny. So no one player actually can take it all. So it requires like a collaboration between different key stakeholders in the ecosystem. Second, our take on the smart cities approach is the IoT horizontal platform. Our approach on the C-ITS, environmental monitoring, smart buildings, and leverage on our ecosystem. The third part is actually, our connected urban transport is our way of addressing the issues, which hopefully will effectively enable the exchange of data in real time for plannings and monitorings and triggered actions when required. And finally, we hope that these solutions, which as part of smart cities mobility topic, addressing that thing, will be able to improve the efficiency, the safety, the transparency, and also in the end help reduce the fuel, improve the CO2 reductions, and help the lesser fuel waste for citizens. So that concludes my presentation. Thank you.